to get everything organized for tomorrow. See how the sound comes through on the stream, cracking my knuckles. You know, this is something I wanted to do. I wanted to move my keyboard because it's on the same plane as my monitor, and I think it makes this kind of deeper thunk than it needs to when I type loud. So I'm going to put it down on the keyboard tray here. Yep. Taking the keyboard out. I'm not going to do the video probably of me just because I'm streaming so early in the morning. I look like crap. And I don't want to have to wash my hair every time I get on stream. Because I'm being a winter hermit right now. Mouse out too. And okay, I did that. Cable's back. It's a total rat's nest back here, but what are you gonna do? Go. Okay, I have to get under here. Secret back. There's the mouse. I guess that's both of them. Okay, good. I had it up a little higher before because I felt like this is a little low for me. And I wanted a little more space for the mouse, so I put it on top of the desk, but there we go. Just take the cushions off. Get a little lower. Okay. Back to the keyboard being here. Okay. So, of course, I got trusty ChatGPT, and now I downloaded Notability too because I had wanted to draw some notes on the screen, and this is a much better solution. Oh, but I am using black. I have to change my ink color. Where do I change the ink color? There we go. Let's do kind of gray instead. Yeah. We're resting on the screen. Let's see what white looks like. White's a little too intense. Okay. That's good. Okay. Oh, interesting. You can do a curve. Okay. So, can do some math stuff. Talking about parabola here. Nice. Can you do like different styles? Ah, yes, you can. Awesome. Oh, that's great. Hold on. Okay. Oof. 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 I'm gonna be making so many notes here. Okay, wait, you can't do. What about shift? Okay. There's this one and little tiny dots. And oh, this is the circle dots. That's good. Cool. Like a pen-like one. Okay. Yeah, what's the pencil? The pencil is. It's got this kind of graphite look to it. And highlighter, of course. Okay. Cool. And go through there. You can see I obviously have my key commands up there. Just so you can kind of make sense of some of these copy paste stuff that I'm doing. Wait, is there a way I can? Maybe I can have that like that so I can always see the chat. Maybe make the chat smaller, perhaps, just because I don't know how many people are actually going to be chatting with me so much. Okay. And then do this. Okay. Nice. Okay. I can just keep the screen up like this and I don't have to rearrange it every single time. That would be great. Okay, so just to test it out a little bit more, I'm going to do a little programming here. did I? Okay, no, I just did that. Okay. Where should I leave off? Triangulation. Not gonna do that. I have to research that more. Yes. Okay, so I wanted to separate the X and the Y iterations. Okay, so how do we do this? Okay. Like horizontal, like gross. And each iterates. Okay. Okay. I always want to put a trailing comma on this. It's just kind of good habit, because then you could come in and just add something else there without having to remember to put the comma on there. Of course, it's going to tell you right away, but it just looks nice. It looks like it's supposed to. Okay, I'm going to... Where was I doing the self.iterers? Self.iterers. So, iterers. Iterers. Oh, interesting. So I have to split this up now too, actually. So, because I have to do X iterers and Y iterers. So, X iterers. Wait, no, because I did vertical and horizontal, right? So, the X spacing is the spacing in between the vertical ones. So it's vertical iterers, and then the Y spacing is between the horizontal iterers. I might be able to come up with a better name than these, but we'll see. Okay, so that vertical iterers, and then vertical line. Just paste that in there. And there. And then and 0 that each to this. Okay. Okay. I think I might be able to set the... Well, let's just make sure this works first. I'm trying to think of like a way, because you're always trying to think about how to conveniently set it up. I don't want to have to every single time specify both of these. So I want to be able to just set one for both of them if that's all what I specifically want. But if I want to specify two, then I have the option to do that, so that we have different numbers of these. Oh, I was doing something in Python there. Okay. Okay, there we go. There we go. Okay. That's okay. So yeah, because it defaulted to those iterers, so we do the iterers. Okay, perfect. That worked perfectly. I love it when things work perfectly the first time. Okay, and then the iterers, like say, no, like whatever, 20. Okay, that works. That works nicely. Okay. But, okay, so now I wanted to check if let's see. This actually will interfere. I just realized. Maybe this can stay over here because I don't really touch this space very often. You can see the shortcuts I'm using over there. Okay. So, what was I doing? I was going to see if I can do this. No, I can't. That's weird. Why can't I do that? I'm just gonna see if I can, if that works anyway. If it's erroring, it probably won't, but. So, yeah. Okay. Weird. Okay, so 10. I might just. I mean, iterations. It's really about lines. So I can rename this. Change all occurrences. Okay, so sometimes that replace symbol doesn't work in this kind of situation if it's not connected to. So if we can try that. Okay. Acted too quickly there. Each lines. Did that work? Where did I? Nope. See, that's why. That's why you got to do this one for this. Change all occurrences. Each. Did I by unselect? Yeah, there we go. Okay, good. Okay, H lines. Why am I doing E on lines? There we go. E lines. 10. 5. Okay. So you can see how that could be useful to be able to define them separately. I wish I could have just a way of I could just define one or the other, but I guess it's okay if they just default to 10 or whatever. And let me just check out the style again. Style equals opted. There we go. Cool. That's fun. Okay. Equal 10. Okay. So 3. Yeah, it would be nice. I mean, this is so nitpicky. Like, maybe at some point, you have to do a kind of overdraw where, like, this one of them goes all the way to the end, depending on the width thickness, because you get this little thing here. But that's so nitpicky. Okay. That's for 2.0. Okay. Okay, I think I solved that issue. I can do. I don't know. I don't think I can do. Oh, but I have to change the print statement down here. That's right. The lines. H lines. And then print. There we go. Yeah, 10 and 5. You can see that right there. V lines and H lines. Just to make it in line. So 10. Yep. 100. Okay, and if I get rid of this, then it defaults to 10. Yeah. And this is great because if you, okay, maybe this is fine this way. Yeah, that's just a finishing fine touch. Like you can delete this, but then if you forgot, oh, it's not just called lines or whatever iterations it's called. Oh wait, maybe I could do that. Yes, I could. Because I could set iterations to nil. Nil. And then in the drawing logic, okay, so okay, so there's, what was that? Something, construction happening upstairs, but it's way too late for someone to be up there. Hopefully something just, you probably laid something there and fell down. Okay, v iters equals, how do you do this pattern? It's like, I get this. Okay, so if iters not nil, then iters else v lines. I think. Why can't you just call it lines? I don't know, lines. Is there any other? I think I just want to do it called lines. Oh my god, this is. If I had people here, this would become a inside joke. Lines. The ends. Okay, so I'm just gonna click real quick. Is this insane to me? Okay, so exact match. It's just that one. Okay. That means if I have just that one, that's okay. Okay, so I can just call it lines. So this is, I'm going over the top here a little bit, but okay, so the iters equals, yeah. Oh, whoops. Hold on. This is the thing that confuses. This doesn't really make sense, but okay. Iters does not equal nil, and iters, like I'm wondering with it. Explain. It's what and is doing. Okay, so yeah, I've used that in other places here. Okay, so v iters equals, if iters not nil, and iters or something the fonts. Unbelievable. Just the way my hands are going. We're doing H Iterers to real. H lines. So iterers and H iter. So I'm replacing this. I'm replacing this here with this variable. It can be either this singular iterers that we'll be able to, in one line, be able to define both the horizontal and the vertical, or you can, if you have one, then it will let you specify the other one. Okay, so let's read this. In lieu of the expression iterers not equal nil, and iterers uses short circuit evaluation, which is a common feature in many programming languages. Here's a breakdown of what's happening. Iterers does not equal nil. Okay, yeah, blah. Okay, and logical operator. And returns the first argument if it is false or nil. Otherwise, it returns the second argument. Interesting. I didn't know that. Wait, so this and it's almost like a okay. And returns the first argument. Or huh. These and I'm not sure if this. Yeah, I mean, yeah, if it's not on that, that's basically what I was writing up here. Okay, so yeah, iters or something. Okay, cool. Okay. I think that'll work. So, and we'll do iters. Wait, no. Is it iters? It's lines. Oh, not lines. Caught that mistake in real time. Thank you, God. I don't know how useful this thing is if I'm just doing the shortcuts so quickly. Okay. So, lines equals 100. Okay, that doesn't look like it's working. Might have an error down here. No? Okay. Why is that? I caught this one, but I didn't push this one. Okay. That's hilarious. What's that doing there? Okay. I just broke that. So, okay, let's do the lines. Okay, so that still works. So, lines. Why is this not working? Weird. Oh, I must be doing something in here that I'm not paying attention to. Wait. Yes, that's what it was. Yeah, because I had to, basing off this, so I need to do by versus each iterates. Okay. Oops. Yay, there we go. Okay. So 20, 30, right? See, so we can just do this in one thing, or but the second that we do each one equals 10. Oh, I think that overrides it. Yeah, so you cannot specify this one while you have this one specified, which makes sense. So then take that out. Now to adjust the print. So okay. If hold on. I think we were doing this. So I need to. This is just like a mess. I think that the point of renaming them as variables up here is that it's basically zero computational effect on this, but it's a little easier to read down here, but at the same time it's just kind of a pain in the ass to maintain. So I'm just gonna go with the self for now and then come back and do another pass when I'm finishing everything up and rewrite this part. Okay. If what is it? Self.lines is not nil, and self.line is not nil. Doing Python earlier today. Code switching between those two. Equals that to string dot lines. I need to learn Vim movements so badly. Okay, I think that will work for this. Okay. The line's 30, you can see it changed there, 30, 40. But then, so if we did, yeah, the H lines is there. Then we take that out. Now it's V lines and H lines. So that pops out. Perfect. V lines equals 30, 40, 40, comma. Perfect. That's nice and flexible. Okay. Okay, I did that. Save that triangulation for later. And I'll just tee up what I'm doing tomorrow. I don't know what I'm doing tomorrow. Starting in the morning, but I should get to bed. Because it's a wee bit late here. Did I finish point? Yeah, the docs, okay. This is gonna be a mess. Working with text is crazy. The more I learn about programming, the more I learn like how insane it must be to like program how text shows up on the screen. Like there's just so much to consider. Even just like a text editor is like a crazy difficult project. You'd think it would be a really easy one to do, but there's once you start thinking about like, okay, well, what kind of data structure is holding this, and like what, especially spell checking and like how that's happening in real time, and when you click your mouse somewhere and you get inserted into this, like what data structure is this whole thing? It's just one long string, one long array. Like that's crazy. Like, yeah. Okay. Okay. Line group. I think these are good. I might be moving on to triangle. I might be dragging my feet a little because I'm gonna revisit this because I have a lot of triangle methods I've actually made already. But I sort of did it before I did all this other stuff and kind of standardized things, so it might be a little, like I don't know like if I need to do this stuff like ABC. Like why would I need this? I was kind of just yeah. I mean, this is the tough thing when you're designing a library. Like I can't see the future uses of these things, but I could. Part of it's like, what am I leaving in here? Okay. Yeah. Yeah. Okay. Because I probably need to do some kind of I wonder. This is, all this stuff right here. Oof, all this stuff is ChatGPT. Like I am not very great at math, but some of these things are just kind of geometric formulas, and you can just ask it to kind of print the stuff out. And, you just test it and see if it works, and then if it works, it works. You can always go back and fix it if you can find some edge case, but you can't quite test things like unit tests with this application, but you can obviously get the immediate visual feedback of like, is it working or is it not? So that's why some of these things, like I don't know what's mathematically going on here. This is one of those things, I can take a second and ask ChatGPT to explain it to me, and maybe I will at some point, but this other stuff I understand pretty well. Because see, I'm not even using like the getters inside of this thing. Because I don't need to. I mean, you're doing it internally. This is a kind of cool function. It analyzes the triangle and then tells you what type of triangle it is. The angle, the type. Okay. I started with this, and this is like a button button tiler function 2, higher order function. But then I realized I have to go all the way back to the beginning and just make like, the very basics. Yeah, okay. I don't need, I think graph I don't need anymore actually. Right? I think I don't. What was this doing? What was this doing that the other ones weren't doing? Let's do this. So E equals graph.new negative 100 just to y max. Okay, I guess I don't have to specify that. And then we got draw. Okay. I see what I did. I added this extra line to kind of show the. Is this useful? Is this useful? In a way that the grid thing isn't. Like that I could. You know, that's another thing I could do. I could make rewrite graphs with the LineGroup function. Draw, say, a line. Thicker line across axes. Okay, that's what I'll do tomorrow. So instead of getting rid of this, because it is kind of useful for debugging, and I do want to add some features to it where you have coordinate labeling or something that yeah, this is a whole other can of worms that I kind of ran into, and I've been sort of making this on the fly, not really looking up anything, and I've done that on purpose because I kind of wanted to struggle through making this from scratch on my own without just copying other people's work. And I realized, though, that graphics programs start from here and then they draw this way and then down, which makes sense because your whole screen, the way your screen works. Oh, I could just take this here. We can do this. So instead of having an XY coordinate like this, you have X and Y here, but Y, this isn't negative Y, it's positive Y. And so this point here, you know, if this is like the units of 1, so you have like 1, 2, 3, so 1, 2, 3, and then 1, 2, this point right there, that's point 2, 3, right? Not 2, negative 3, 2, 3. And that's surprisingly hard for me to conceive, because then this one down here is 3, 4, 5, 6 is 2, 6. And everything in my brain is screaming at me that this is above, the 2, 6 is above this one. Just hard for me to deal with. Okay. So the issues that I'm running into is that I kind of designed this thinking, okay, yeah, people will, you know, if you're drawing like shapes and doing some fun things with LFOs, removing stuff around on the grid in different things, you know, different unit circle or whatever, morphing things around, just kind of a visualizer. You'd want this grid, you know, the Cartesian plane. And then I thought, okay, if you're going to draw something like a module, and oh, that's what I wanted to do. Okay, do this real quick. I'll finish what I'm saying. I remember now. Okay, that if you start from down here, and then yeah, logically you place things relative to this point. I mean, you spend most of your time in math class in the first quadrant, so like you would think that you'd start like here, where you know you have X and Y this way. So, and since I have to figure out how to accommodate both naive users like me who might find it difficult to do the programming aspect of it, on top of that they also have to learn this part, but then, you know, they could draw this way where this is the origin, or people who are more advanced who are coming into this library with the assumption that it's going to start here and then being confused when it's down here. That's something, you know, because basically I have to figure out a way to, like, you know, get these functions to work where they can work in two different ways, where everything's flipped or not. I don't know. We'll see how that does. I could maybe just rotate the whole thing. I don't know. There are several functions that will take the whole. You can imagine that there's a coordinate system underneath this that you can't see, and then there are these built-in functions that you can call that will rotate or do different things to the scale and rotate right here, right? And scale will take the whole coordinate system and expand it so that, you know, this one little square will now represent like this, you know, 3 squares here. So like that point will shoot up to there. The problem with I stay away and actually don't use any of these translate, scale, rotates, because they're doing something that I can't then reflect in the debug information, the output, because, you know, you can have something that you have coordinates at a certain place and then you rotate it. Well, if you rotate the thing and then you save it and restore the canvas transformation, because you actually have to save the transform state, you rotate it and then you restore it. If you do that, then you the coordinates that you're using in that shape are relative to this wonky, like, other, you know, imaginary invisible canvas that you can't see, and they have no relation to these other things, so they act in unpredictable ways. So you actually have built-in translate scale methods for all of the shapes that we're going to do at the lines and stuff, or like the line it finds it's late, whereas translate right, this is different because this is drawing characters and there's really no way to do this without that. But okay, so translate, right? And we're creating a new line based on this translation that we're making, this translation that's getting made out of these arguments here. And we do rotate. See, it's the pivot finds the center of the line, or you can select another pivot at a different point, but it finds the line and then uses that to rotate the line around it. And then we use these the vectors. Actually, the underlying this doesn't have its own, technically doesn't have its own rotate function. It's actually calling the underlying vec2s to rotate around. Well, so you go in here, and this is why this class has so many functions. And so this is the actual math that's going behind the rotation, where you're doing this, finding this translation. Okay, so yeah, I'll do that. Oh, and what I forgot something, but then I remembered. Yes, I remember. Okay, because I wanted to do. I'm just gonna do like a little like notes up. I want to do background class. I could just read this, right? Background. Yeah. What I want is a background class that would exactly match, like, up to the line right here of the module, and then you would be able to change the color of the module, and you would just be able to create a background. And you would have to input, obviously, the size of the module to it, but otherwise, once you had the size of the module and then you get the origin point aligned correctly, then it would just match it exactly. So let's do background class. I should be putting this in GitHub and doing all that kind of stuff. Right, whole other window to put up. GitHub is where I largely, when I'm just like out and about and I'm thinking of things, and I just dash off something quickly on my phone to, like, as a reminder to myself and the issues. But I guess we could look at the Let's say confirm. Issues. The issues here. Okay. Oh, I already put that there. I already had this idea. Oh yeah. What was this about? Look at the. So there's some expensive operations that Vec2 does that when you have thousands of things in green, that it might be better to cache those things if they're not being recalculated everything. So basically anything that involves division is something that is more expensive, and it has expensive like trigonomic functions, and you could cache the result of something and then and you might be able to save some stuff, but that's something I think about. So, and then the tree, I need to add a tree class. Yeah. The tree data structure will help me for a lot of things, but most specifically the layer class, and that's coming. I mean, I have a primitive kind of version here where you can add something to a layer and then determine programmatically the order that it's being drawn in. But yeah, back up on it, so it's always the lowest layer. The layer is going to be kind of the crowning part of the 2D part. I think it's going to be the most complex because I'm going to have to. You want to have, I got to draw this. So you have a root. Oh, turns into a little square. You have the kind of global layer, right? So this is like the G, really lazy G, global layer. You can have all of these other layers that exist on the same kind of global space, right? And this one has, we can write in here the z index. So this one has a z index of 0, and this one of -1, this one of 2, and like, let's say negative inf, right? Negative inf. I need a stylus so bad. So the z-index determines the order in which things are drawn. So this one will get drawn first, then this one, then this one, then this one, right? So this is first one, second, oh, whoops, sorry. First one, second, I actually do this in a different color. So first, second, third, fourth, because as you go from negative values to higher values, this is drawn first, and then as the higher the z-index, the closer to like the viewer it is. And so these could be all in like kind of the same plane, but then within a layer there could be other layers. So we have within this layer, it could encapsulate other layers. I'm not going to do this for all of them. I'll just do it for this one. And I have other layers here. And of course, inside of these layers, what this does is you can add an object to a layer. And so you could have a circle, and you add this circle to this layer, and then you have a circle on this layer. And if the circles overlap, if you have two circles that overlap like this, so like here's one here, and then if this is, you can say like this one is the negative inf one, and you have another circle that's drawn on top of it. So this circle was drawn first, and then this circle gets drawn. this. So that's how the layer system works. You draw objects one at a time, and then the other object gets drawn on top of the other one. But what would be cool is that you'd be able to programmatically influence where the layer the z-index is. So you can shift things around the z-index dynamically based on input. So I could kind of swap the order of this blue and red circle so that the blue would now be over the red. And so that's all fine. This is essentially what I have right here. Does this layer, just this one layer here. Where it gets more complex and where you actually start to need to implement algorithms is where you get into a tree structure. So you have you can see this is like the root node, and then it's sort of like an inverted tree. So this is going down. I forget what these are called. They're called nodes. Yeah. So you go down to the node, and then these ones would be leaves if they don't have anything else in them. And so, for example, like these could have their own local z-indexes within this layer. And so I could do -1, 0, and 1, right? So this one is getting drawn first, second, third, right? But if we look at this all together, is this first, second, and third within this order? No. You go first draw this one, first you draw this one, then you go to here, and then you look inside of this layer, and then you draw this thing, and this thing, and then you draw what's ever in here, right? Because you might have an object inside of here. You might have an object inside of this layer, like a circle. Yeah, circle. And inside of this layer, you might have a square. Big square. All right. And this layer, well, let's see. I'll explain this one. So say these are both 0 z-indexes, right? And so you have a rectangle here that's in this layer right here with a z-index of 0. Then which one gets drawn first? Well, this one gets drawn first because it's lower, and we draw everything at this layer, and then we go up to this layer. And so this, while we're in here, everything below this has been drawn, and then we go over here and then we draw the blue circle. So it would look, something like this, right? So this blue circle's on top of this square. And then furthermore, we get into this other issue where we want to have an object. So you have two at the top layer, at the global layer, you can only have layers here. But then underneath here, I will have this one. So this one at the side, inside of this layer is an object. And inside of this object are layers, right? And this object, you can imagine it being like a snowman, right? You have a snowman. You have 3 shapes there, and you have the 2 eyes, and then the 3 buttons. And these are all points or circles. You have lines for this. And you can imagine, you see how I'm stacking up all these shapes, and this is this one snowman that's this object that's getting drawn here at this layer. But we have all of these other things, like, for example, I drew this quickly, but you can imagine this circle is actually like the lowest circle, and then this circle gets drawn on top of that circle, and then this one gets drawn on top of that. So we have a z-index that orders the drawing. So this is the lowest z-index to the highest, and then we add the buttons on top of everything, and then maybe the hat is like the highest z-index of all, and the last thing that gets drawn. So we order those individual elements here, and then because we can do fun things with them, like you could take the hat and you could call the rotate function on it, and then rotate the hat, kind of like tip the hat to someone. But then you'd also be able to, in this layer, rotate the whole layer. And then what that's going to do is it's going to look for, and here's my little imaginary line that I'm going to draw. It's going to look for what's called the bounding box, which is the very farthest outside of everything that's in the snowman. And then based on this bounding box, it's going to look at the center. And then this center, back to this. It's going to look at the center, and it's going to rotate around that center. Or whatever other point that we, if we can define a point here, the pivot could be here, and then we could rotate the whole snowman around the pivot that way. But, by default, you would rotate this one whole object together. And now what that has to do is then it has to go into all of these other objects and go down into the decomposed layers and then tell those objects, okay, I'm going to, you're all now all rotating around this center point that I calculated from you all together here. But you're going to call your individual rotate functions, because there's no way to kind of like, I don't know, print these objects together, like, and save them as one object and have that, like, because as you're going through the script, every bit of the snowman is getting called to these different objects, these different, like, this is a different circle object, that's a different line object. So you have to go down to the individual line and circle class and point class for the eyes and rectangle for the hat, and call their own separate rotate functions, because they'll all be kind of different based on that. And then even underneath that, there you have the vectors that they are being the ones that are actually doing the rotating. And so you can then, of course, have within a layer, you can have another object in here, right? So you can see how quickly complex this is. If I kept it at one layer like this is already implemented here. It's a few lines of code. But once you start adding this tree data structure, you'll have to, the algorithm, what it's going to have to do is it has to traverse the entire tree. And I forget exactly which algorithm. It seems like I should do depth first search. And go through I'm going to have to traverse the entire tree, all of these layers, and catalog what their z and indices are, and then sort a list that is going to be the order in which to draw everything onto the screen. And once I have this list, then it's easy. You just iterate through it and you call that object's draw function. And so the trick of this layer system that I'm developing here, and that I'm sure this is how it works in plenty of other applications too, is the trick of it is just getting this this sorted list. So you have it's a cool kind of project, and hopefully one that I can show off to potential employers. This is kind of a complex system. All this other stuff is relatively simple compared to this. You have this data structure. You have the Z index, and you have the complexity of, you have to have the parents keep track of their children, and the children keep track of their parents. That's actually how they're referred to. Like, this is the root or the parent node of this node, and then this is the child node of this node. Child node of this node. I should probably draw, because it might be hard to see. And then you're going to need to traverse the tree to make the list, and then you need to use another sorting algorithm to sort the list, and by z index. Which would be interesting. That's an interesting project to work on. That went way longer than I thought it would. I just thought I was popping in to do a little test, but I ended up doing a whole dang stream. So this is a lot of fun. I hope you got something out of it. Maybe I can, I don't know, edit it a little bit take out the keyboard part when I put it up on YouTube or something. But yeah, I will be up bright and early in the morning. See you then.